Pressure differential systems. Overpressure protection of firefighting lobbies with smoke extraction compensation. Electronically controlled air transfer is SMAY's answer, providing automatic smoke extraction air compensation problems occurring with buildings equipped with constant capacity smoke extraction systems protecting horizontal escape routes. The common solution is to supply compensation air to the firefighting lobby. In order to allow for the flow of air with the doors between the lobby and the corridor closed, air transfer damper is installed in the wall dividing the aforementioned spaces. When the doors are opened, air flows from the lobby into the corridor, both through the door and the damper, ensuring that both the lobby and the stairwell, used as an escape route, are free of smoke. In order for the installation to function properly, correct air release should be ensured. If the designer does not pay attention to this detail, operation of the lobby air supply installation will cause overpressure, both in the lobby itself and in the adjacent corridor. Then, during evacuation from premises on fire, smoke will easily penetrate the corridor and subsequently into the lobby. It could also result in the stairwell being filled with smoke. Designing appropriate air release in the corridor will ensure that the smoke will be extracted from the corridor. Air may be extracted by mechanical smoke extraction installation or natural, for example, a window ventilation may be used. The detrimental effects of external factors should be taken into consideration if using natural ventilation. For example, strong wind blowing at right angles to the facade with the window may cause a zone of overpressure, which will, if the doors between the corridor and the stairwell are opened, prevent effective extraction of the air and smoke mixture. As the air and smoke is not being extracted, it may flow into the stairwell. However, in practice, investors wishing to maximize the usable area of the premises decide to reduce the lobby. This means that there isn't sufficient space to install the air transfer dampers with appropriate dimensions. In such a situation, the supply of a large amount of air to the lobby will cause an excessive increase in pressure, making it impossible to open the doors and evacuate safely. It also happens that, for aesthetic reasons, architects do not allow for the installation of air transfer dampers, as these, due to their intended use, are quite sizable and interfere with the aesthetics of the interiors. An alternative solution to air transfer dampers is the use of an electronically controlled air transfer, which constitutes a duct with two branches, one to the firefighting lobby and the other to the corridor. Each branch is equipped with electronically and mechanically coupled multi-blade dampers. The system also includes a regulator with two pressure measurement points, one in the lobby, the reference in the corridor. The proposed system is an answer to the smoke extraction air compensation problems for corridors operated by constant capacity smoke extraction fans. The idea behind this solution, in the event of all the doors along the escape route being shut, is the simultaneous supply of a small quantity of air to the lobby, producing an overpressure at a level of 45 Pascal, and the supply of compensation air to the corridor, protecting against excessive pressure reduction within that space due to the operation of the smoke extraction fan. When people begin to evacuate, doors between the lobby and the corridor are opened. When the doors are opened, pressure in the corridor and lobby will equalize, and this acts as a control signal for the system. This results in the damper in the duct leading to the corridor to shut, and the entire air volume is directed to the lobby. The air flows through the lobby doors into the corridor and is removed, together with the smoke, by the smoke extraction installation. Then, when the doors between the lobby and the corridor are closed again, pressure will rise in the lobby, which again acts as a control signal for the system, which begins to operate executing the pressure criterion. Advantages of an electronically controlled system. It solves problems associated with smoke extraction air compensation if using constant capacity smoke extraction fans in the corridor, reduces the dimensions of air transfer dampers. In practice, due to the limited size of firefighting lobbies, it is often impossible to install properly sized air transfer dampers. Ensures precise control of overpressure in fire lobbies and continuously monitors the operational parameters of air transfer devices, by which acceptance tests and periodic commissioning pressure differential systems tests for buildings are completed faster.